video, I'd like to talk to you about variable length subnet masking, or what we refer to as VLSM. Now, VLSM varies from the type of subnetting we've done in the past, because the subnetting we've done in the past was traditional subnetting, which meant that you would have the same subnet mask for every single subnet. So that's how it differs from variable length subnet masking, because the term variable means changing. So what that would mean is we could use a different subnet mask for each network. Why would we want to do that? Well, as you know, with IP version 4, the addresses are depleting. So in that previous scenario, we were using the same subnet mask for all the networks, which is great on these LANs. But did you notice how we were actually kind of wasting a lot of addresses when we really only needed 2 addresses for the serial links? So that's where variable link subnet masking would help, because you can accommodate for the number of hosts on each LAN. So look at this scenario where I have 10 hosts here, 20, 30, 35, and then we have 2 here for the serial link. So that's what I have drawn here. We could spend a lot more time talking about variable length subnet masking, but we'll just go right on to the scenario, because you'll be using VLSM throughout the remainder of the semester. In the real world scenarios, this is what's actually used and not traditional subnetting. So you're probably wondering why we learn traditional subnetting. Well, without learning traditional subnetting, it's very difficult to jump straight into VLSM. So we're looking at the scenario, and what I've actually done is written down each of these from largest to smallest, because that's just the method that I use for VLSM. If you have another method that works for you, then great. But this, if you're not sure how to do it, this is the method that I use. So I just write down largest to smallest. Now remember, with subnetting, traditional subnetting, you would have to figure out how many networks you need. You don't really have to do that with this, because you're accommodating for hosts, and when you accommodate for those hosts, it will automatically accommodate for the number of networks. So how's that? Because this is the 35 network, this is the one with the 30 hosts, 20, 10, and 2. Well, that's 1, 2, 3, 4, 5, and that is 1, 2, 3, 4, 5 networks here. So that's how it automatically accommodates. So what we do is kind of look at each one of these individually and walk through the same steps we did for the traditional subnetting. So for 35 hosts, when I start with that, I'm asking myself, how many bits do I need to have in my host side in order to accommodate for all the addresses, to provide enough addresses for it? So I ask myself, do I need 1 bit? Nope, that would only give me 2. 2 to the second is 4, so that's not enough. The third, 4th, 5th. So I need to go down and borrow 6 bits. I need to have 6 bits in that host side, because 2 to the 6 is 64. That would give us enough to accommodate for 35. So if I were to do that, I'd do 1, 2, 3, 4, 5, and 6. And I'm going to draw a line here. So that would give me the number of bits that I would need. Now, let's kind of look at where we are with this. I'm going to pick up a different tool here. So this is the 0 network, right? Right there where that period is, okay? Because we had 8 bits left over. So this would actually be where our /24 would be, correct? So that's /24. So if we put these bits, remember this is the network side. Network side. This is the host side. So we have 2 to the 6 over here, right? Okay. On this part for the first one. 2 to the 6, and we already said that gives us 64, right? Okay, that was that first one. So if we have 2 of those bits that are used for the network side now, this line up here extends out to the /26. And I'm going to go down here and show you what each of these would be, or actually we'll put it up here. So if I'm looking at 35, and I'm going to draw a line here, I think it'll let me. So we said that's going to be a /26. We already said 2 to the 6 is 64, so that's what it's going to increment by. So let's go down and figure out what it is for 30. So for 30, we need, let's see, 1 bit won't work. 2, 3, 4. 2 to the 5th would accommodate. 2 to the 5th equals 32. So if I were to go over here, 1, 2, 3, 4, 5, I'm going to draw a straight line there because that's what we need for that one. So going, now we have 3 bits in the network portion. So in this scenario, this one is going to be a /27. So over here, this one is going to be different than the other one. It would be a /27. And we said 2 to the 5th down there accommodates for 32 bits. Okay. So let's look at the next one. So the 20. So let's see, 2 to the 1st is not enough, 2 to the 2nd, 3rd, 4th. We're going to need to use the same one, right? 2 to the 5th equals 32. So that's also going to be a /27. It'll allow up to 32. So let's look at the 10. Okay. So for 10, 2 to the 1st is not enough, the 2nd, 3rd, 4th. So 2 to the 4th would be enough. So 2 to the 4th equals 16. So 1, 2, 3, 4. So that would be right here. That would also be a /28. So I'm going to go back over here. So that's going to be a /28. We said it accommodates for 14. Now we have this 2 down here. Now, you would think that 1 bit would be enough when you first look at this, because 2 to the 1st equals 2. But you have to remember for each of the host side, you can't use the network address and you can't use the broadcast address. So if we use 2 to the 1st and it came up with 2 numbers, one being the network and one being the broadcast, then we would have no usable numbers. So you really have to go up to 2 to the 2nd. 2 to the 2nd equals 4. So if I were to go to 1, 2, it would be right here. Okay. And that would be a /30. And the /30 accommodates for 4 hosts. And I'll give you a hint, you'll always use a /30 for your serial links because there's always the same number. It's always going to be 2 for serial links. And then you have it, so you have a network number, 2 usable addresses, and your broadcast. Now, you see where I have written over here all of these numbers. Okay, you don't necessarily have to do that, but I do it just because it makes it a little bit easier for me, okay, to remember, because I'll show you. Once you get this part down pat, you really just have to do the math on it, and that's it. So it makes it a lot easier. So we know we started off with a .0. So .0 we know is going to be our first number. So all you have to do is do the math on it. What is 0 plus 64? 0 plus 64 is 64, right? So that's the next network number. So to figure out the next network number, 64 plus 32 is 96. Okay. So 96 and 32 gives us our 128. 128 and 14, okay, you add 128 and 14 together, it gives you, what I believe it is, 144. Okay, so these are each of our network numbers. These here so they all. These are each of our network numbers, so your broadcast number just follows one below. So if the next network number starts with 64, well then this one has to end at 63. If the next one here starts at 96, then that one has to end at 95. If this one starts at 128, this one has to end at 127, the next one begins at 144, so this one has to end at 143, and then this one would go through 147. So that those are your different ranges. What you have to remember when you're doing this is not to get caught up when it's moving from one to the next. For example, in the scenario here, okay, you have to accommodate for this line. So you really kind of have to block out what's on the next one and say 0 plus 64. Okay, so 0 plus 64, and then bring that down. This one, 64 plus 32, bring that down. 96 plus 32, bring that down. 128 and 14, and bring that down to 144. Otherwise, you'll start looking at this and getting it all kind of mixed up. But you have to remember you have to accommodate for 32 numbers on this line, 14 on this line, 4 on this line, and so forth. So these are each of our network numbers. And if you're looking at that, you have to also figure out what your mask is going to be, because you have to remember your mask is going to be different for each one now. You're not going to be using the same mask all along. So for a /26, so this is where that CIDR notation comes in, where I was telling you remember your subnet mask. So for your /26, if I'm looking at it over here on this line, okay, for example, how do you figure out your mask? 128 plus 64. Then on the next one, you had /27, so then that'd be 128, 64, and 32. So that'd be all three. And then the next one would be 128, 64, 32, and 16. And then the next one would extend out. I'm sorry, that should be coming around the 4 there. So that's how you figure out your mask. So over here, grab the correct tool. So the /26 would end in a 192 mask. All the numbers here would end in 224. Same with this one. So 224. Here it's 128, 64, 32, and 16. So they're going to end in the 240. And then here, this will always be 252. So how do you apply it on this side? Well, over here, you have to make sure these line up. That's the biggest thing. You can't just kind of randomly start assigning. Like, for example, the 35, we need to make sure we apply that one to the 35. Because if you start applying the 35 subnet to the one that only has 20, I mean, you're going to have extra addresses here, and then when you get to the 35, you're not going to be enough. It's kind of like waiting on tables in a restaurant or being a hostess. So if you're a hostess and you have all these people, so you have a group of 35, a group of 30, a group of 20, and a group of 10, and then you have this couple that comes in. So there are two. Well, if you start grouping people not in the right area, somebody's going to be upset. So you take the group of two, and they don't care that they're in this big group, which has 35 people. They got lots of extra chairs over there, and it doesn't bother them. But you're not going to be able to squeeze the group of 35 into the area that's set aside for two. And the other reason I usually go largest to smallest on this is because it's easier if you think about it in terms of like a hostess setting. So wouldn't it be easier to set your group of people like 35, and then your group of 30, and then your group of 20, and then kind of just work in your groups of 10 or your groups of 2 in with the larger crowds, rather than just randomly sitting the groups of 2 down, the group of 10, and not thinking about your larger sizes? Anyway, I don't know. That's how I think of it. So this is what I would use. So if you're looking at your 35, then that is going to be your .0 network. Okay, 0, and I would go ahead and do my slash notation, 0/26 network, because you're going to have a new mask. So then if you're using your first available address, okay, for your default gateway, that would be .1. My last available over here would be the 62. Now I'm going to go to my group of 30. So this would be the .64 network with a /27. That would mean this Ethernet interface would be 65. That means this would be a 94. Then I would go over here, and this would be my 96 network, .96 with a /27. This would be the, let's see, what would this one be? .97. And then this one would be .126. Then I'm my group of 10. And let's see, this is the .128 network, which means my first available would be the 129. Then my last available address would be the .142 address, because 143 is the last usable. Like I missed the number here for this one. Let's see if that should be .126. I think I missed the number in there somewhere. Okay, so this gives me all those, and then we have our serial left. So serial, this is the .144 network, and then you have 145, 146, and then 147 is your broadcast. So you just have to remember when you go into each of your interfaces and configure them that you're using the same mask. If you ever get an error, you're not using the same mask, you're using the mask that you've accommodated for. If you ever get an error message that says overlapping IP addresses, that means you did something wrong in your subnetting, so you want to go back and check that. But otherwise, this is an example of how you would accommodate for VLSM and how that would apply to an actual network. So if you have any questions, feel free to send me a remind text or either send me an email.